All right, so simplifying each trig expression. Let's see. Okay, we have some nice properties that we can apply here. We know that cotangent of negative x, that's an odd identity. So cotangent of negative x will just become negative cotangent of x. So we just pull that negative out in front and just continue to simplify from here. And because cotangent is negative cotangent of x, I can expand that into something in terms of sine and cosine to make it a little bit matching with that left side. Kind of maybe work towards common denominator. So now that I have my two fractions in terms of sine and cosine, I'm going to find my common denominator. My common denominator will have to include both these terms. I could do some balancing here. This fraction is missing a sine x, so I need to multiply the top by sine x. This bottom portion, the second denominator is missing a 1 minus cosine. So I get sine squared x minus, I'll distribute the cosine through, so negative cosine of x plus cosine squared x. So now that I have everything under the same denominator, I can merge the two numerators together. I know sine squared plus cosine squared equals 1. So I have 1 minus cosine of x up in the numerator. Denominator, I get 1 minus cosine of x times sine of x. I can see matching factors there between my numerator and denominator. I can remove them. I'm left with 1 over sine of x. That's same thing as cosecant x. Number 2. These are cofunction identities here. So we have cosecant of pi over 2 minus x. Cosecant and secant, right, are going to be cofunctions. So I can replace this cosecant of pi over 2 minus x with secant. Cosine negative x, that's an even function, so I can just remove that negative altogether inside that cosine. Sine is odd, so that negative is going to come out in front. The two negatives will become positive. And tangent is even function. I'm sorry, tangent is odd function as well, right? Tangent is odd function as well. So negative tangent. So what if I just turn everything to be in terms of sine and cosine? So this is 1 over cosine minus cosine over 1 minus sine x sine over cosine. Let's see if common denominators will help me get to my result here. I got 3 fractions. Each fraction can have a common denominator of cosine x. The first one and last one is already in terms of cosine. It's just that middle I have to merge here. So I need to balance that with the cosine x up top. Hey. Okay, so cosine squared minus sine squared. If I factor a negative 1 out, I get cosine squared x plus sine squared x. There's an identity here. Cosine squared plus sine squared is 1. So 1 minus 1 is 0. So 0 over anything is still going to be 0. So answer choice E. Okay, good so far?
Yes.
All right, number 3. Cotangent of x minus pi over 2. Cofunction as well. But notice that it's x minus pi over 2 instead of pi over 2 minus x. So that's just going to change my sign here. So the negative is going to come out of that. So I have 2 negatives, which makes it just positive, and cotangent turns into tangent. Okay, so if I can get that tangent to be in terms of sine and cosine, so again, I'm thinking common denominator here. Balance each of the numerators here. First denominator is missing the 1 plus sine x. Distribute the sine x through. Second denominator is missing the cosine x. Okay, merge the 2 fractions together. The numerators can all be put together here as well. Sine squared plus cosine squared is 1. I'm left with sine x plus 1. Okay, common factors, remove them. One over cosine is secant. So yes. Okay, number 4, maybe it helps to get those squared to be outside the expression, so we kind of see them a little bit more clearly. Okay, so cosine is even, so the negative goes away. Sine is odd, so the negative gets pulled out, but the squared is going to force it back to positive here. So negative sine times negative sine is positive sine. So this is really cosine squared plus sine squared. The fact that that sine is an odd function is negated by the fact that the squared is going to force that negative to be positive. So it ends up being both being positive. Cosine squared plus sine squared is 1. So we're left with 1 over 1 minus tangent squared. Oops, sorry. This is a minus sign in between. Okay. Messed that up here. So it's not quite equal to 1. Let's see. Cosine squared minus sine squared. With that, let's see. Then we need to get everything in terms of sine and cosine. Let's see here. Cosine squared. Okay, let me play with that denominator here. Okay, all right. So if I get everything in terms of sine and cosine, looks like that matches a little bit better here. There we go. Okay. So got that tangent in terms of sine and cosine, matched a common denominator, balance the fraction. Now I can divide this cosine squared minus sine squared by this expression. Dividing by a fraction is the same thing as multiplying by its reciprocal. Cosine squared minus sine squared goes away. I'm left with cosine squared over 1. Is all right, good so far.
Yes.
Let's see here, number 5. Looks like I can handle these cofunctions here. So cofunction of cosine is sine, cofunction of sine is cosine. What if we get everything in terms of sine and cosine? I can write this as 1 over cosine of x for secant, 1 over sine of x for cosecant. multiplied by its reciprocal. That becomes sine over cosine. So I have sine over cosine plus sine over cosine. Both of these are tangents. So it's really just tangent plus tangent, which is 2 tangent. Okay, so answer choice A. Okay, secant to the 4th of x minus secant squared of x. What if we did GCF? Right, so let's say they both share a secant squared, so I can take a secant squared out of both. So taking out a GCF is the same thing as dividing by that GCF for both terms. So secant to the 4th over secant squared is secant squared. So secant squared x minus 1. So secant squared x minus 1, we can use trig identity there. We know that 1 plus tangent squared x equals secant squared x. Secant squared x minus 1 is just tangent squared. Let's see. Well, looks like my answer choice here is in terms of tangent here. So maybe I can work towards tangent from here. So I can convert that secant squared to be 1 plus tangent squared x. And if I distribute that through, it looks like I can make that option D match with me here. So distribute the tangent squared through. Okay, everything look good? Or do you have any questions?
Yeah, everything looks good. I don't really have any questions. Thank you again.
Okay, do you want me to go over anything else in the packets?
I think I'm okay. But
All
thank
right,
you again.
sure. Have a good day, Justin.
Have a good day.
That one person.